welcome to the Reactions Test Online Practice 2017. Here's a series of 6 different reactions, kind of summing up all the things that we've learned for Unit 4, or the Reactions Unit, in this year. So let's take a look at how you do these problems. If you're looking for extra practice, this is it. This reaction here is a single replacement. Lithium replaces hydrogen. And you might want to just double check that it happens before you do anything. Is lithium above hydrogen on these activity series? And clearly lithium is the top. So this reaction does proceed. So let's write it down here nice and neat. Lithium plus, this is carbonic acid. And, oh hello. What happens is now lithium goes with carbonate. Lithium is +1, carbonate's -2, so you'll need 2 of them. Oops, sorry. And then hydrogen's by itself, but hydrogen's a sneaky 7, so you're going to want to have a 2 there. And then when you balance it, you're going to need a 2 out here. So there's the first reaction. Second one is what we call a combustion reaction. Combustion reactions are really nice because it's just a simple process. Always the same reactants and products. Carbon dioxide and water for the products there. And then balance it by putting a 4 for carbon and 10 for hydrogen, so 5 times 2 is 10, and you add up all the oxygens on this side, you've got 4 times 2 is 8, plus 5 is 13. So ideally you'd like to have a 6.5 here for 13, but you tend to write whole numbers instead. So instead of 1, 6.5, 4, and 5, we go with just double all of them to 2, 13, 8, and 10. Hope that's not sloppy enough. This is an 8. Oh well. Strontium and bromine in a synthesis reaction. Strontium and bromine is a sneaky 7. That's why it's included there. So when you use that, rewrite them there. Strontium is +2, bromine's -1, and so they end up, when you crisscross and get SrBr2. No need to balance, already done. Here's a double replacement reaction of potassium phosphate and copper 2 nitrate. And when you do this reaction, the outsides go together, which is potassium nitrate. And insides, copper is +2 and phosphate's -3, so Cu3PO4 2 after your double replacement. After your crisscross, I'm sorry. And then when you balance it, let's see. Gonna want to go with 3 coppers here, so put a 3 there. That gives you 6 nitrates, so 6 here. 6 potassiums, 2 times 3 is 6, 2 phosphates already there. This fifth reaction is called a decomposition reaction, and it includes a sneaky 7. It's cesium iodide, breaks apart into cesium, but also breaks apart into iodide, which is a sneaky 7, so it gets a 2 there. And then when you balance it, you should also put a 2 there and a 2 here. And the last one kind of encompasses everything that we've done so far in terms of reaction writing and then doing all of the net ionic and that kind of stuff. You've got tungsten 3 fluoride, so you need that first. Tungsten, in case you're unclear, +3, fluorine's -1. Ammonium is +1, hydroxide's -1. So when you crisscross them, tungsten and fluorine go together, you get WF3. And you also get ammonium hydroxide, that's NH4OH, because they cancel out. And then they double replace. So tungsten goes with hydroxide. Tungsten is still +3. And ammonium and fluorine are both +1 and -1, so NH4F. And then you want to see if there's a solid. So ammonium is almost never a solid, right? Ammonium, always soluble. So there is your AQ. And then hydroxides usually are solid except group 1, or ammonium, barium, strontium, or calcium. And I've got tungsten, so there is your solid right there. And you should balance it also by putting a 3 here and a 3 there. Okay? So I did mark the solid with an S. If I want to write the total ionic equation, I break everything up. That's AQ. So this is AQ, this is AQ here. Break it up, keep that together, and then break this one up as well. So to do that, I'll have 1 tungsten, which is +3, and 3 fluorines, which are -1. I've got 3 ammoniums, which is +1, and the 3 distributes, so I also have 3 hydroxides. Then I keep the solid ones together. That's the tungsten 3 fluoride, or hydroxide. Write a little S so we don't forget. And then on this side, I've got 3 ammonium and 1 fluorine. Or sorry, 3 fluorines. So there is what we call the complete or total ionic reaction. The spectator ions are the ones that repeat on both sides. That would be the 3 fluorine and the 3 ammonium on both sides. So I would write, you could write the 3 if you want to. You don't need to, but we have 3 fluorine and 3 ammonium. And then if you cancel those out and get rid of them, what you have left is called the net ionic reaction. So what's left is W plus 3, and 3 hydroxides minus 1. Each of those are dissolved in water. And then you also get, as a product of solid, you keep that together too, WOH3, and write a little S there. So there is a quick review of some kinds of problems that you're likely to see on this year's reactants test. Okay, bye.